these two stalwarts, what I like to do is, you just got a whirlwind tour of what applied AI looks like, and this was really more a helicopter view. So we're going to crash land a bit and see what the view from the ground looks like, because Ram, as a partner with CloudSide, is involved in a lot of the on-the-ground implementations, and Giri, as a customer with Lending Cart, is actually implementing a lot of those financial services use cases that I talked about. So it would be fabulous to get a more realistic perspective than I could have provided from both of them. Thank you so much for joining us. So Giri, one question for you to start with. One of the things we've traditionally struggled with in your space, which is Lending Cart, is that when you do lending to customers who do not have rich credit history, there isn't enough historical data to feed your models. So how is your data science team really helping customers understand, or rather helping your teams understand customers better and their risk profiles better in the absence of all of that rich credit history?
Right. Thank you, Seema, for the talk. I mean, there's a lot of innovation in this space, and I think this is a very pertinent question, right? I mean, if you look at lending and the lending industry, traditionally it's been around how do I prevent something. We take a slightly different view to that. We say that there is various stages in the financial growth of maybe an MSME or an individual, right? How do we enable them to get credit? So that's the point of view. So if you sort of invert the premises and say that let me avoid giving credit to someone and say that this is customer first, let me make sure that I figure out how can I enable someone with credit. So new to credit customers, they don't have bureau history, they probably have never used a credit card, starting a small business, they need working capital. Initially, that tends to happen maybe through their friends and family, right? And then the bank account of the business sort of has some cash flows. So if you look at it, for a lender, that cash is the collateral, right? The ability of a customer to pay back sort of depends on how the cash is coming in and out of the business. And that's exactly what we use to make sure that we identify the risk profile of a customer. Again, while we say that we identify the risk profile of a customer, what I want to say is that we try and figure out if the customer, everyone is credit worthy, right? So we try and figure out what is the amount that, we can lend to the customer, at what interest rate, will they be comfortable paying back? And the third one is, when we do that for a certain tenor, what is the chance that they may default? And that helps us control the non-performing assets. So this is the view that we take in, and this is what our data sciences team sort of works on in our primary product, Seema.
Thank you so much, Giri. Your chat reminds me of this book called Human Plus Machine, which I remember Paul Doty from Accenture had written. And it's really about using human judgment to make some of these decisions that you just mentioned, in addition to what a model can give you. So it really has to be manual judgment plus artificial intelligence in that sense. Ram, one question for you. You are a partner who helps implement a lot of these technology solutions and make it real for customers. So you might have developed a lot of accelerators that help customers speed up this journey. Can you share some examples of accelerators that data scientists use to tap into the cloud-native pipelines that they're trying to build?
Sure. Yeah, thanks, Seema. I think you also covered a lot of things during your session about the same topic. So as a data scientist, right, like right now in today's world, it's not enough if you just build models. You have to actually deploy it. And the statistics were very right. It's not just because the model isn't performing. There's no process to actually make sure that model iterates and then it gets built with a new data set and then gets deployed in the right way in production environment with the right amount of testing, right? Unlike traditional applications where when a feature is iterative, incremental, you only have to be sure about the incremental part that you did. But let's say even 10 wrong data in a training data set could entirely remove the accuracy of the model overall. So that is where the challenge is, and there are a lot of accelerators that, in fact, Google provides that we have been using with our customers. I would like to touch upon the pipelines part that you asked, right? Like the there are like a lot of open source pipelines as well, like Kubeflow, TFX, TensorFlow Extended, which are actually, again, like Vertex pipelines from Vertex AI is built on these kind of pipelines. And these pipelines, they don't just help in like probably pushing data into your model and getting the results out. No, right from like dataset creation and how do you prepare data for your model, and like let's say if you want to do certain feature selection, etc., and remove all the unnecessary features, do certain encodings wherever necessary, and then next part is the training, and not just training, like train with multiple set of models, do A/B testing before even deployment, and you rightly covered model monitoring, right? Like what happens if you train a model and they don't perform well? And would you do a separate app just to monitor this? No, that there is no time for doing all of that stuff, right? So that's where model monitoring that comes as part of the pipelines help. So these model monitoring, these monitor the statistics, the bias, if there is any, the skew, and if there is any drift, concept drift that's happening, and then it will notify, and not just notify the invoker, but it would also make sure the right alternatives are done. Let's say if you find a skew, do not deploy this model, or probably retrain the model with the latest data set and all of that. So these are the things that are like pre-built and readily available. And our job is to ensure that we fit all the pieces in the right way so that these pipelines run end to end. Yeah, so that's one misconception that I want to clear. Like it's not anymore getting data in and getting data out of the model, but end to end.
Absolutely. Yeah. Thanks for sharing that perspective, Ram. One of the things that has always struck in our customer conversations as well is AI is really the 20% of the iceberg that you see above the water. Data and data quality is really the 80% that you don't see and is not as obvious. So often we start getting all excited about use cases and we say, all right, let's build this and let's build that. And then we turn back and say, all right, we've got the funding for this now. Where's the data and is it of the right quality and so on? So from your perspective, since you've had quite a bit of maturity in building out some of these models, what are the steps you have in place from a data perspective to ensure that you have the quality and quantity of data to feed these data-hungry models?
Right. So, Seema, it's a problem that we all face, right? And it all sort of starts with a good hypothesis. And you might have a mountain of data, but a lot of it might not be relevant. So it's an iterative process, I would say, and that is where Google published this paper called "The Hidden Debt in Machine Learning," right? And it says that there's about 8% that actual data sciences work, and the rest of it is all ML ops, how to clean stuff, and all that. But I think there's two things that I would like to emphasize on, right? The first one is that you have to constantly iterate and test. Second thing is that you have to get to a space wherein that there's this right set of features. And you mentioned the 12 odd billion data points coming down to about 3 billion data points, right? That is the iterative process. And there needs to be a lot of focus on that. Not always more is better, right? And any sort of tools or technologies that sort of help us to get there is very useful. Right now, it's more of an art. But we've had models wherein we've gone from 10,000 data points to very few data points. There are certain cases in which we understand that there's just 2 or 3 features that are most dominant in a machine learning model, and the ability to identify that comes from the understanding of the domain. So that domain is very, very important, right? That domain expertise is very important. And that sort of brings me back to how do you work, right, with the domain experts and sort of remove that silos between the machine learning engineers and the domain experts and get iterating on models. Now, the moment you reduce your feature set, it also means that you can reduce the amount of data that you need. And oftentimes models tend to go obsolete. I mean, think about COVID, for example, right? Or maybe a black swan event like demonetization. Overnight the model needs to change, right? Yeah. So we at LendingCart have a process wherein we are able to iterate on these things a bit faster, and that comes with a heavy understanding of our customer, the domain, and the right tools that we use.
Thanks, Giri. You couldn't be more right about it. I think we've had people preach minimalism in lifestyles and minimalism and everything else. You're saying minimalism in data as well. That's one good mantra I'll take away from here. One question on data privacy, security, that's been a lot on our minds as well, particularly with evolving regulations. So, from a fintech perspective, where it particularly hits those businesses hard, how are fintechs really dealing with those evolving regulations around data privacy and data localization?
Right. So, like I said earlier, right, we are very measured in terms of what we collect from the customer first. You see a lot of fintech apps asking for permissions to do everything on your phone, right? I mean, your contact addresses and whatnot. Most of it is not relevant. And whenever a regulator sort of comes in and says that, hey, here is what you should be doing, they consult fintechs like us. We work very closely with RBI, and there's a reason behind why they do a lot of this regulation. And a good measure of it is set around a set of principles, right? One is that you need to be transparent. You have to tell your customer what is it that you're doing and why, right? Second thing is, why has a certain inference come out from your data? You need to be able to explain it. Third one is, you don't get consent forever, right? You need probably a camera access maybe for doing a video KYC, and that's valid for 6 months or more, right? So just for that once, you take consent. So the regulation actually is, helping that customer, and we try to adhere to a lot of this, and particularly in the case of localization and privacy, the availability of cloud infrastructure within the country, right, across multiple geographical locations has made it reasonably easy for us. And we are also constantly looking at technology, right, saying that, look, you don't need personally identifiable information at all stages of maybe lending. You need specific information at specific stages. Do you use statistical inferences, right? Rather than going really deep into, okay, let me pull this customer, let me grab all the data that they have. I think taking that nuanced view is important. And, personally, I'm looking forward to technologies like homomorphic encryption, where I could draw inferences from data that is not really readable in some way, right? So I'm looking forward to those innovations being more commodity as well.
Absolutely. And I think we've had technologies that really encrypt data even as they enter your system. So not as bothered about where is it lying and how is it lying. So yeah, data at rest, data at motion, both being encrypted sufficiently. One point that also resonated very well with me was the point you made about localization. Ever since we launched our second data center in the country last year, we've had tremendous interest in not just using it as a DR or a backup in a second region, but also for the reason that your data is going to remain within the country and still you have a DR and a backup mechanism right there. So I think just working with cloud providers who can actually provide that localization by having multiple data centers within the region is critical.
Absolutely.
Thanks for sharing. Ram, one question for you around fintechs again is, fintechs have a great interest in use cases like underwriting, forecasting, and prediction, and so on. What has been your experience implementing those kind of use cases on a platform-based stack like a Vertex AI versus trying to do it all manually?
Okay, yeah. So one of the interesting things is over the course of last few years, right? The entry barriers for ML have been removed significantly. If you look at I'm sure a lot of people from the audience would also echo this sentiment. If you look at a platform like Vertex AI, right, out of the box, it provides a lot of tools that you could use, like AutoML. AutoML has something called Predict, and AutoML has its own classification. And all you have to do is you have to make sure you have the right data set that can be fed to the model. If you, Giri also mentioned this point, domain experts getting along with ML engineers, right? That trend is also changing a little bit now with platform tools like Vertex AI. Earlier, like Giri mentioned, both teams were working in silos. The ML experts did not probably understand the full things of the domain, people who are on the ground. And vice versa, the teams do not understand the limitations and the capabilities of ML to exploit it or use it fully, right? But right now, with the platforms like this, it enables the people on the ground, the domain experts, to go and try out things and then take help from the ML teams or at a later stage. Well, let's say a domain expert from fintech, like from Giri's team, probably without programming knowledge as well, he could, as long as he understands his data set completely, he could just go and use a tool like BQML, write SQL queries, get predictions out of it, understand, like probably write a model for understanding the creditworthiness of a particular customer. Or he can move to a platform like AutoML. Again, like a lot of feature engineering is automatically like inbuilt as part of the solution. You just point it to the right data set, understand the inference, look at the explainability part of it, like where feature importance, etc. And then go back to the ML engineer saying, hey, this is what I understood, this is what the data I have, and this is what I think the model is capable of. Why don't you iterate on this and probably improve it a little bit? And these kind of things, right, from our experience we have seen, proof of concepts which used to take weeks and months have now been reduced to days, right? In a matter of 5 days, you could just, as long as your data set is ready again, you could just deploy one model, actually, in fact, like multiple models, test them, compare them against each other, and then go to the next step. And things like these, like enablements from platforms like this, like would help companies like LendingKart not to disrupt this industry once, but repeatedly.
Thank you. Thanks. And this point came up so many times in just our own discussion right here, that you've got to get teams to work together. And the more you think about MLOps, it's really clear that there is a software engineering aspect to it, there's a data engineering aspect to it, and then there's the data science aspect to it, right? So it's really at the intersection of all of these. Could you tell us a little more about how you get these teams practically to work effectively together? Do you have any strong DevOps practices or MLOps practices that you follow that you can share with us?
We do have a lot of DevOps practices, but there's one important point, right? I mean, as a company, we take a customer backward view and we start working with a few metrics, and then we start pulling together people who are sort of required to move that metric, right? And now, whether it's SDLC or something else, it's a mechanism to enable that. Having said that, I think people have not yet, in a lot of companies, taken a view of the life cycle, right? I mean, software development life cycles are probably fairly mature. Data engineering life cycle is not yet mature. Machine learning model life cycle is not yet very mature. And while people talk about APIs in products, right, they don't talk about data products. They don't talk about machine learning products as much. So there's a vocabulary around it, right, which is starting to develop. And we, buy into that vocabulary and then, work together. So, and naturally, frameworks come in, do data scientists follow an agile methodology or not? So I think it's a combination of things that have been coming together very well and working for us. So, the statistics that you showed on the slide in terms of failures of machine learning models, right? We are able to avoid that because of these practices. Having said that, the ability to experiment, we need to get better at that. And I think it's okay to fail in a lot of cases, but fail fast and then, generate impact.
Thank you so much. That was really insightful, Giri, and thanks a ton, Ram, for sharing your experiences. Hope this was an insightful conversation for our audience as well. Thank you very much.